Hello, my name's Kathy Nguyen. I'm a student at UC Berkeley studying data science and business, and I just wanted to hop on here to give a little math tutoring demo. So yeah, to get started, let's do the first problem. The first problem is a statistic problem, more specifically probability. So it reads, in a bag, there are 8 red balls, 5 blue balls, and 3 green balls. 3 balls are randomly drawn from a bag without replacement. What is the probability that all 3 balls are of different colors? So first, you'd want to see how many total balls there are. So that would just be 8 plus 5 plus 3. That would equal 16 total balls. So let's take, for example, a red ball being the first ball. The probability of that would be red over total. So there are 8 red balls, as we said earlier, and the total is 16. Let's say draw 1. Draw 2. Let's say it has to be a different color. So let's say blue, for example. So blue over total, that would be the probability of getting a blue ball. There are 5 blue balls still because the first ball was red. But now the total amount of balls is 15 because you already took one out, which was red. You drew one which was red and you took it out. You didn't replace it. So there's only 15 total. And you kind of see that pattern. So we'll continue. The last one will be green because it has to be a different color. Okay, there are 3 green balls, and in total, there are now 14 balls left in the bag. So to get the probability that all 3 balls that are taken are of different color would be each of these probabilities multiplied by each other. And we can just leave it as an expression. So that's the answer to that one. The next question is a system of equations, and I'm going to be solving it in a linear algebra type style using a matrix. So yeah, if you're not familiar with a matrix, it is a table with just the coefficients of the equation. So in this case, it would be 1, 5, 7, -2, -7, and -5. And it makes it a simple way to solve system of equations. So 1, 5, 7, -2, -7, and -5. And I have this line here just to kind of separate it because this side will be the variables and this side will be what the variable is equal to. So this row kind of represents X and this row represents Y. And this would be, like I said, what it's equal to. So how it works is you want to basically isolate it so that there's one value in the X column and the rest are zeros. And same for Y. You want one value in the Y and the rest are zeros. So that it could be X equals this value and then Y equals this value without any Y in the X equation and no X in the Y equation. So to do that, first let's try to get rid of this -2. To do that, you want some number plus -2 to equal 0 because you want to cancel this out. So this value has to equal 2 because 2 minus 2 is 0. So to get this value to equal 2, you have to multiply. 1 times 2 is 2. But you have to do it to the whole row. This is called Gaussian elimination. If you want to look more into it. But yeah, 2. And you'll be multiplying each element in that row by 2. So in this color, I'll just write. So you kind of think about it in your head. You could write it out, but it's much simpler if you think about it in your head, so you don't have to write as much. Yeah, so 2 times 1 is 2, 2 times 5 is 10, and 2 times 7 is 14. So now you draw another, you draw another matrix. You'll keep the first row as is, and I'm going to keep it with the simplified number before multiplying it, just for simplicity's sake. So 1, 5, 7, draw that line. And then now row 2 is equal to row 1 plus row 2. And of course, in row 2, we multiplied by 2. So in other words, this element right here, the number here would be 2 plus -2, which is 0. And this would be 10 minus 7, which is 3, and so on. 0, 3, and then 14 minus 5 is 9. So perfect. We got to isolate 1 here, and there's no other value. So this x would equal some value, but the problem is there's still a y component. We want to make that 5 into a 0. So to do that, it's kind of difficult because 5 times some number equals -5. It's a little bit difficult. So for simplicity's sake as well, we're going to divide each of these by 3 so that we get 1 and 3. So that now we can do 1 times -5 is -5, and -5 plus 5 is 0. So same like before, I'll just do -5, and it'll go to each one to get 0, -5, and -15. So we'll just copy row 2 down. So row 2 was 0, 1, and 3. And now row 1 equals row 1 plus row 2. And row 2, we multiplied by -5. So this value here would be 1 plus 0. This value would be 5 plus -5. And this value would be 7 plus -15. You get 1. You would get 5 minus 5 is 0. And then 7 minus 15 is -8. And that's how you solve it. So this, again, this would be the x column. This would be the y column. This would be the value. So you go horizontally. X equals -8. Oops. This y would equal 3. And that's how you solve it. So in linear algebra, of course, you go more complex, but that's the gist of using matrices. For the sake of time, I won't do this problem, but if you tutor with me, we can go over this and where we'd solve H using a matrix as well. Lastly, I wanted to cover a calculus problem. So this is a free response question coming from the Calculus BC AP test from 2022, if you're curious. So first, this graph, we need to read that it's the graph of f prime, and the problem gives you some information like that. That's important. The graph consists of a semicircle and 2 line segments. So first we need to find f of 0. So first, we're using what we have. So we have f of 4, and then to get from f of 4 to f of 0, we need to use the integral of the derivative to see the net change. So you want to add you're starting at 4 and you're trying to go to 0. So from 4 to 0 of f prime of x. And because that's not how we typically do it, the integral of, let's say, 2 to 1 equals the negative of 1 to 2. Using that information, it'd be f of 4 minus, we change it to minus 0 to 4 of f prime of x dx. And the question here told you, is f of 4 is 3. So we put, 3 minus, now the integral from 0 to 4 is a circle or a semicircle. And the formula for a circle is area, oh my goodness, sorry about that, area of circle pi r squared. And you can see the radius would be 2. So pi r, or we got r is 2 squared. But then it's a semicircle, so we want only half of that area. So your answer would be 3 minus 2 pi. Similar for the next question, we could do it up here. So f of 5 would be equal to f of 4 plus the integral. We're starting at 4 and we're going to 5, f prime of x dx. And in this case, we don't need to use this because it is going from a lower number to a higher number, so we don't need to flip it. So again, we know that that's 3. So from 4 to 5, you can see that this shape makes a triangle because you're trying to find the area under the curve. So it would be a triangle. So the area of a triangle is half base times height. So here the base is 1 and the height is also 1. So 1/2 of 1 times 1 equals, I guess you could put 3.5. Yeah. Yeah. Thanks for watching. Bye.